Hello, we are back with Chapter 6, Lesson 3, using properties with rational numbers. And we're looking at example 3, which is a construction application. What this states is the soccer team uses 36.75 liter container to take water to games. The team manager fills 0.75 liter bottles from this. He has used 22.5 liters. How many more 0.75 liter bottles can he fill before he runs out of water? Write and solve an equivalent equation without decimals. So we need to figure out what is the key information. Well, the soccer team uses 36.75 liter container. So they bring this big old container to the games. And then each bottle that they fill, it has, the bottles are 0.75 liters each. Now, he's already used 22.5 liters, and we need to figure out, well, how many more bottles can they fill? So first, we're going to set up an equation. The thing that we need to know is, what do we not know? And it's usually found in the question. How many more 0.75 liter bottles can he fill? So it's really how many more bottles. So we're going to let X equal the number of bottles. Okay? Now, when I am solving or setting up an equation for a problem like this, this is a type of problem where we have a total of something, and then the total is made up of pieces. Okay, so we have a total amount, and then we have pieces of that amount, which are usually like piece 1 is added to another piece. Okay, so let's look at this. The total amount would be the container of water, which is 36.75. That's going to equal the individual pieces that make up that 36.75. It says the team manager fills 0.75 liter bottles. Okay, so that's how many liters each bottle is, but we don't know how many bottles that we can fill, right? We still need to fill bottles. So that's going to be our X. The number of bottles multiplied by 0.75 is going to tell us how many additional bottles we can fill up that hold that much water. But there's the other thing is he has used 22.5 liters. So that's another piece. He's already used 22.5. So the 22.5 liters that the manager's already used plus the 0.75 liters times the number of liters, those two are going to add together to make up the total amount. So we have our total amount, and our total amount is comprised of these two pieces. Now, that is the equation for this particular example. Now, what we're going to be practicing is this is a normal two-step equation. It has decimals. We could figure it out. We have skills to figure out what X is. But what we're going to do is we're going to write and solve an equivalent equation. So we're going to write and solve an equation that is the same thing but without decimals. Now, how we do that is we have to figure out, well, what is the decimal place, the biggest decimal place that we're working with? So here, for 36.75, this is the tenths, this is the hundredths place. So far, the biggest place value is the hundredths. Here, 0.75, another decimal. This is the tenths, this is the hundredths. So that's consistent. Here, it's just the tenths place, okay? But the biggest place value would be the hundredths place. So what we're going to do is we're going to multiply this entire equation by 100. So this side of the equation and this side of the equation we're going to multiply it by 100. So we're going to go 100 times 36.75, and you're going to see what's going to happen when we do this. And then we're going to go 100 times 22.5 and 100 times 0.75 x. So 100 times 0.75x plus 100 times 22.5. So we multiply everything by 100. And this is a trick. And the trick here is just to get rid of all of the decimals. So whenever you multiply anything by 100, you can move the decimal place 2 places. So you can move it here 2 places to the right, 1, 2. So easy way, 100 times 36.75 is the same thing as 3,675, which is going to equal 100 times this. You just move it 2 places, and now we have 75x. And then 100 times 22.5, you move it 2 places, 1, 2. There's nothing in that place, so you have to add a 0, which is the same thing as 2,250. Now we have our two-step equation without any decimals, and so we can just go ahead and solve for x. I mean, we can solve the equation with decimals, but they want you to learn how to write equivalent equations without decimals, and this right here would be that equivalent equation. So let's go ahead and figure out what x is. We know that we have to keep this 75x together till the bitter end. So the first thing we need to get rid of is this 2,250. So we're going to do the inverse operation of addition, which would be subtraction to both sides. We're going to subtract 5 take away 0 is 5, 7 take away 5 is 2, 6 take away 2 is 4, 3 take away 1 is 1. And we just, these cancel, we drop the 75x down. And now we just need to get x by itself. Right now it's being multiplied by 75. No sweat, we can do the inverse operation of multiplication, which would be division to both sides. So yeah, 75 divided by 75 is 1. So we're left with x. We just need to figure out what's 1,425 divided by 75. Let's just go ahead and do it. We have to do the long division. So let's go 1,425 divided by 75. 75 doesn't go into 1, it doesn't go into 14, but it does go into 142, but it only goes in one time. I know that 2 times 75 is 150, so that would be too much. So it's just going to go in one time. And we subtract, and that 2 is not big enough. We have to borrow, making that a 3. So it's going to be 12 take away 5, which is 7. And then 13 take away 7, which is 6. And then that's less than 75, so we know we did it correctly. And then we just need to drop that 5 down like it's hot. And then we need to figure out how many times 75 goes into 675. Well, I don't know. I'm not sure. I'm going to guess and say that 75 goes in there 9 times. And so I'm just going to go ahead and figure out what 75 times 9 is. I know that 9 times 7 is 63, so it's going to be close. And 75 times 10 is 750, so that's way too big. So I'm guessing it's going to be 9. 9 times 5 is 45. Write the 5, carry the 4. 9 times 7 is 63, plus 4 is 67. So yeah, there it is right there. 75 times 9 is 675. So it goes in 9 times. 9 times that is 675. There's no remainder. So yeah, x equals 19. So the, what does it want to know? How many more 0.75 liter bottles can be filled before we run out of water? So we'll say 19 bottles can be filled. So there we go. Perfect. All right, let's go on to the next example. Check it out, example 3. So, yeah, so we're just going to go for it. It says if the soccer team uses a 42.5 liter container, about how many 0.75 liter bottles can the manager fill before he runs out of water? So, this one is a tad bit difficult because I am not sure if we're taking into account this 22.5 liters that he's already used or not. This looks like a continuation of this problem, but I'm not exactly quite sure. So we're not going to worry about that one. This is just going to be our example right here. Okay.